Hi guys, so today we're going to go over vertical and horizontal asymptotes. So vertical asymptotes are the zeros of the denominator. Mind you, you can never have a zero in the denominator, so they're the x values that your function can never be. Graphically, they're the vertical line that your function will never actually touch. It could approach that value, but it can never actually touch that particular value. And how it relates to the domain is that vertical asymptotes, again, are the zeros of the denominator. Those are all the values of x that we can't have in the function, whereas the domain are the x values of the function. So a quicker way to find the domain a lot of times is just to find out, instead of all the x values that the function can be, is just finding the vertical asymptotes and seeing what x values you can't use for the function. So from here, we're just going to work with the problem. I'm going to write it in a more legible fraction form. So for the first function, I'll write it up here, x minus 1 over x minus 2. Now, here, all I'm doing to find the vertical asymptote is I'm finding the zeros of the denominator, which just means I'm setting my denominator equal to 0. And that will give me, adding 2 to both sides, x equals 2. And if you look at this function graphically, if I were to draw a straight vertical line at x equals 2, because when it's x equals to a number, that makes a vertical line, by the way, the function will never actually touch that value. It'll just approach it. And I'm doing this because I can't draw straight lines, so I'm just noting that this is where x equals to 2. Now, for number 2, I know you just want to set the denominator equal to 0 because that's what I just showed you. However, I do want to show you an exception that might happen, and it might not even happen in your lessons or your assignments, but it's just something to keep in mind because it could. So make sure that you simplify your rational function if possible before setting the denominator equal to 0. So what do I mean by this? Well, in the denominator, you can factor that. And there is a saying, if you can factor it out, you can divide it out. So using the factoring method I showed in the other videos, I'm going to multiply first times last, and I'm out of room, so I'm going to put that up here. I need two numbers that multiply to be 8 times c, which is 10, and add up to be the middle number b, which is 7. So two numbers that multiply to be 10 and add up to be 7 would be 5 and 2. And over each number, you would put ax. A, mind you, is the coefficient of x squared. It's just 1, so you don't have to put 1x. You could just put x. And there's nothing to reduce here, so these are my two fractions that will correlate to become my two parentheses. So instead of x over 5, that will say x plus 5. And then x over positive 2 will say x plus 2. And again, if you can factor it out, which mind you, there's nothing here, so it's just a factor in itself. If you can factor it out, you can divide it out. Also keep in mind, x plus 5 divided by x plus 5 is an actual value. I'm saying this because the x plus 2 does not magically move up. So x plus 5 divided by x plus 5 is 1. Your simplified rational function is 1 over x plus 2. And that's the denominator you would use to find the vertical asymptote. So if I set x plus 2 equal to 0, I will get a vertical asymptote of x equals negative 2. Which correlates with the graph of this function, because if you look at where x is negative 2, that would be where a vertical asymptote can be drawn, which is a dotted vertical line. What happens here is there's a hole in the graph. Nothing you have to worry about now. You may have remembered it from Algebra 2, but just kind of noting, if you can simplify it before finding the vertical asymptote, just make sure you're aware of it. Okay, moving on to horizontal asymptotes. They are related to the range in the same manner. Horizontal asymptotes are the y values that don't work with your function, whereas the range are all the y values of the function itself. So the nice thing about horizontal asymptote is that there's no actual work to it if you know the three conditions. So keep in mind that n is the numerator's degree. Degree is just another way to say the largest exponent. And m is the denominator's degree, which is the highest exponent for the denominator. A and b are the leading coefficients of the numerator and denominator. Coefficients are the numbers in front of the variables. So the leading one, the leading number in front of x for the numerator and denominator would be a and b. So writing number one in a more, I guess, fraction-friendly visual form, I have x squared plus 3 over x plus 5. So again, I am just going to take the numerator's degree, n, which is 2, and the denominator's degree, the highest exponent there is 1. If there's nothing there, remember there is a 1, just like there's a coefficient of 1 in front. So m equals 1. Now, if I compare n and m, n is less than m because 2 is, sorry, 2 is greater than 1. Um, n is greater than m, so 2 is greater than 1. So what happens is we look at the conditions. If n is greater than m, there is no horizontal asymptote. And that correlates with the graph because there is no horizontal asymptote that would break up this graph. Moving on from here, we have 2x minus 7 over x plus 4. So I'm going to look at the two leading degrees again, the two leading exponents. N is equal to 1. M is also equal to 1. So what happens when N equals to M? We have the horizontal asymptote y equals to a over b. Just going to show you here. If n equals to m, y equals a over b. And remember, a and b are the two leading coefficients of the numerator and the denominator. So the leading coefficients, again, coefficients are the numbers in front of the variables. The leading ones are in the front, so that would be 2 over 1, which would give me y equals 2. Which makes sense because if I go to where y is 2 and I draw a dotted horizontal line again, the function will never actually touch that value. It'll just approach it. Okay, so last one, and it's going to be 5x minus 1 over x to the third power minus 2. So n is the numerator's degree, which is 1. M is the denominator's degree, which is 3. In this case, if n is less than m, what happens? Well, we have the horizontal asymptote, y equals to 0. But if I draw a horizontal line at y equals to 0, it crosses this point right here. So I do want you to be aware that there are exceptions to the rule with horizontal asymptotes. It doesn't happen often, but it could happen. So I specifically chose this problem just to show you that, don't doubt yourself. If it happens, it could happen. There are exceptions to the rule. So I hope this helps.